Thank you for the introduction, Tracy. As Tracy alluded to, my name is Mike Jervanak. I'm a senior sales engineer with our KBS sales department here at Greenheck. And today we're going to be talking about what's cooking. So the latest design trends in kitchen ventilation. So with that, what are we cooking? What's on the menu today? We're going to start with a KBS market and components overview. So this is going to be a very high level overview of the KBS market as it stands today. And then some of the products and components that Greenheck comes to market with through Holden. We're not going to dive into the particulars of the products themselves, but I just want to give you a high level overview of what Greenheck can do. And just know that if it moves air in a kitchen, Greenheck has the quality products to make that happen for you. Next, we're going to go into design considerations within kitchens, followed by the evolution of kitchen ventilation design, and then wrapping up with the DOAS factor in kitchens. So where are we kind of moving to? DOAS certainly becoming a more predominant product in the kitchen ventilation sector. And then finally, what do we do for you? So what can Holden do for you all to make your day-to-day lives easier? The one thing that I will say here is that the intent of this presentation is to be very design heavy, with the idea that when you come to Holden and when you're working with your sales engineers, these are the design considerations that they're taking into account. You all certainly need to know these things, at least on a high level, but I would really advocate to lean on your Holden reps to actually go ahead and put your selections together and get the budget quotes and any of the selections that you need back so you can drop them into your bid specs. But you guys certainly need to understand this on a high level so that when you're speaking with clients on the front end, you're able to understand what's important to them and what design constraints or limitations are there in a kitchen, and then you know what budget concerns do you have. So with that, we're going to move into the KBS market overview and components. First and foremost, a lot of this is going to be a review for a lot of you, I would imagine. But I'm going to point out, what does KVS stand for? So KVS stands for Kitchen Ventilation System. And you're going to hear me highlighting the word system a lot of times through this, because historically in the market, we have, the mechanical engineer is responsible for above ceiling, and then the food service equipment consultant or dealer is responsible for the design below the ceiling. So what happens with this? We have one system and potentially two entities. So again, and potentially even three entities if there's a controls contractor involved in a project. So as inevitably happens, this project gets to a job site and then somewhere in the scope, something got missed, and who is accountable for what? I would advocate that the HVAC, so the mechanical engineer, should be responsible for the HVAC in the entire building, because ultimately that's how we're going to balance this building and to make sure it's a successful construction. So the kitchen ventilation system should be within the entire mechanical scope from hood all the way up to the fan. I always tell the little story. I can speak from personal experience. My fiance is actually a food service equipment dealer herself and love her to death. But when it comes to HVAC and air movement, she doesn't know what she's doing. She's not trained in that avenue, or she's not trained in that discipline. You all are. So that's, again, I would leave the food service consultant to decide what countertops to use, what flooring to use, how are we going to make this thing look, and how is the menu going to flow? And the HVAC expert should be responsible for the entire kitchen ventilation system. So moving on from that, we're going to talk about the kitchen ventilation system component. So what all goes into this system that I keep mentioning? Again, this is going to be a high-level overview of the system itself. If you have specific product questions related to Greenheck product, feel free to put that in the chat function, and we'll make sure to get those questions answered at the end of this presentation. So we're going to start with the first component of the system, and that's the hood. This is pretty basic. We have a type 1 or a type 2 hood, and it all comes down to, hey, is there grease in this application? Is there grease being produced within this hood system? If so, you need a full KVS kitchen ventilation system with a type 1 hood and all the components that we're going to talk about. If no, if this is truly heat only, or if it is condensate, we have our type 2 product offering that we'll bring to the table. The most common question that I get, because this is pretty straightforward, the most common question I get from the engineering community is, hey, I have an oven. Do I really need to have a full type 1 system and all the costs associated with that? And the answer, unfortunately, really comes down to the local authority having jurisdiction, as I'm sure you guys are used to hearing. But the example that I always use is a very common one that we'll get is, hey, we're doing a bakery that has an oven in it. Can we put that under a type 2 system? In my experience, the local code authority is going to kind of go to the worst case scenario. So they're going to say, okay, it's a bakery, that's great, they're doing baked goods, but is there potential down the line that that bakery could say, bake a bunch of bacon and then crumble that bacon up and put it on its donuts? If that possibility exists, then most authorities are going to require a type 1 hood just if the possibility exists out there. So moving on to the different exhaust hood configurations, we're going to start with our basic hood configuration of a wall canopy exhaust hood. So this would be a standard 24 or 30-inch tall wall canopy exhaust hood hung 80 inches off the finished floor per ADA requirements. If you have a low ceiling application, we can do a tapered front hood. So that can be tapered in 18, 15, or 12-inch front heights. And that reduces the overall front of that hood so that you can hang this in a low ceiling configuration. The next hood configuration would be a double island or a double wall canopy back-to-back in an island application. So what this is it's 2 of these wall canopy hoods hung back-to-back to each other for when you have back-to-back appliance lineups, so you can have that large capture footprint. The next is a low proximity hood, or commonly referred to as a 5-guys hood. So these hoods are going to be hung about 36 inches above the appliances with actually an underhang requirement. And since they're so close to the appliances, they have a lower CFM requirement typically. These are used, like I said, a 5-guys hood is kind of slang for them. These are used in a lot of fast food applications where you have fryers and griddles. But as soon as you start having ovens or really hot charboilers or something of that nature, the low proximity hood is no longer very effective. The final configuration would be a type 2 or a heat/condensate hood. So again, this would be a type 2 application. You can have condensate baffles in these to knock down condensate over dishwashing applications. Now here, I know that everybody's muted, but I always get the question of, hey, Mike, you're missing one. You're missing an island configuration. Where is your single island hood with a V-bank configuration for an island application? And Greenheck does produce these hoods, but the way the market is moving is typically now folks are using a wall canopy hood hung in an island application with a finished back, and then you just extend the length and the width. So you extend the overhangs of these hoods and you increase your CFM. And that's just where the market is going. It's largely driven on cost. The V-bank configuration has a high cost point compared to the wall canopy because you have double the filter racks. So again, Greenheck still produces our island style hoods, but the market is moving towards a wall canopy hood in an island application with a finished back. Moving on from hoods, the second component of a KVS system is your fire suppression system. So type 1 hood, if it's a type 1 hood, it needs to have fire suppression. So there's 2 types there. It's going to be either appliance specific, standardly your Ansel R102 system, or it's going to be your full flood or overlapping coverage. Now the big difference here is cost. So the full flood overlapping coverage is going to be way more expensive than your appliance specific configuration. And most of the time what we're seeing, I would estimate 95% of the time, 95% of our projects that Greenheck is putting out, we're going with an Ansel R102 appliance specific fire suppression system. And that's really based on cost. When would you use a full flood or an overlapping system? In my mind, there's really 2 scenarios. One, if you have a true test kitchen where they're constantly changing the appliances underneath the hood. And I mean a true test kitchen when this is happening on a weekly or monthly basis. I use the example, I actually office out of Minneapolis, Minnesota. And I use the example of we have Target Corporation here in Minneapolis. And Target has a lot of Greenheck hoods in their test kitchens because when they are going to brand their food, or if they're going to test new food that they're going to put on their shelves, they need to understand how that's being cooked, what the nutrition values are, and so on and so forth. So they're constantly changing their appliances in order to be able to test things. The next reason you would use an overlapping system is if it's required by a local jurisdiction or by a specific building. Again, using a very specific example, in Bloomington, Minnesota, we have the Mall of America. And the Mall of America has just stated that it's going to have an overlapping fire system And that's just going, if you're putting a type 1 hood in there, you're going to have an overlapping system. A lot of times I'll hear from engineers, well, hey, I don't know the appliance lineup, so I'm just going to be safe and do the full flood or the overlapping coverage. And this is where I would really encourage you to reach out to the food service consultant or the food service dealer who is, or the owner ultimately, who's doing the appliance lineup. These appliances are very expensive, and in most instances, they know when they're going to need what their appliances are going to be, so you could do an appliance-specific system. Moving, and I should mention, Greenheck, we partner with either Ansel or Amerex for our fire suppression systems. Ansel being kind of the Kleenex tissue of the world, Amerex just being a competitor to them, and both systems offer an overlapping or an appliance-specific option. Ansel R102 is probably the industry leader. The next item that we're going to discuss is the exhaust fan. So the next part of the kitchen ventilation system is how are we exhausting, or how are we actually moving the air out of the system? And that's going to be with a UL 762 listed fan for type 1 systems. Will be UL 762 listed. For a heat or condensate, it would be UL 705. But know that Greenheck, again, I'm not going into any of the particulars of the product. If we need to cover that afterwards, I'm happy to do so. But Greenheck offers a full line of UL 762 listed fans, whether that be a sidewall fan, a traditional cube up blast exhaust fan with a hinged curb cap, a utility set fan. Now I need to update my rendering to be a vertical utility set. So this would be a UL 705 listed fan. If it was 762, then this would be in the vertical configuration. And then finally, our inline exhaust fans can be UL 762 rated as well with a motor out of the airstream. The one design consideration for you guys to factor in here is for upblast exhaust fans. Keep in mind that code is going to state that the discharge height of the wind band of the exhaust fan needs to be 40 inches above the roof deck. One common thing that I'll see missed is that people forget to calculate the fact that there's going to be 2 or 3 inches of insulation on the roof. So then they have their wind band to be at exactly 40 inches, when with that insulation, it's actually more like 38. Can be fixed if you get called out for it with a wind band extension, but that's just a common thing to consider. The other question I get from engineers quite a bit is, do I need a vented curb or just a standard curb? The answer really is that it differs by municipality. And it depends if they're wrapping their fire duct with insulation all the way up to the intake of the exhaust fan, or if they're stopping the insulation wrap at the roof deck. If they're stopping it, you would need a vented curb. Moving on to kitchen makeup air. So this is going to depend by region. And I think down in the Georgia region, sometimes you will see untempered makeup air in a kitchen ventilation system. This is becoming less and less popular, or we see it less and less, but it certainly does happen. We're going to go in, when we're talking about design considerations and the current state of kitchen ventilation design, we're going to touch on why you temper air and what the question to tempering makeup air in a kitchen is. But just know that Greenheck has the product, no matter the situation, to go ahead and provide your makeup air. So we have our untempered units, our direct fired heat only, so our DGX makeup air units. And then Greenheck also offers the package DX, split system DX, our heat and cooling options, as well as our DOAS units, or our RV or our RVE unit, which again, we're going to go into the design considerations behind DOAS a little bit further on in this conversation, but Greenheck has the product offering to meet all your needs. Moving on to controls. So here's where we're going to slow down a little bit and talk a little bit more specifically about controls. What does code call for? What is the right design criteria when doing controls? So no matter the manufacturer, you're going to have two types of controls out in the market. You're going to have a constant volume design where you're going to have a constant volume control center or a variable volume control center. What the control center is going to do is the control center will be the brains of this system. So it's going to tie those exhaust fans and those makeup air fans together. It's going to provide a temp sensor. Greenheck puts our temp sensors in the actual exhaust hood, the exhaust cavity of the exhaust hood in order to sense temperature 5 times faster than the competition. But when the code is going to require that when the kitchen is in a cooking or is operating, when the appliances are on, both the exhaust fan and the makeup air fan need to be interlocked together in order to operate. So the way these control panels work is they're sensing temperature. Our minimum set point is typically 92 degrees Fahrenheit. So when our temperature sensors sense 92 degrees Fahrenheit, even if the cook has not turned on the hood, maybe they just came in, turned on their appliances, and went to the back and started doing prep, the kitchen system is going to come on per code, and that's going to happen because of the temperature sensor. Now, the next big thing in the market is variable volume. Variable volume, just energy consumption, is kind of the wave of the future. From a cost perspective, these have come much closer in recent years. The price between a constant volume system and a variable volume system has reduced drastically. This is mainly driven by the fact that Greenheck and ECM direct drive motors, those ECM motors, so our very green motors, don't require VFDs. They just need a 0 to 10 VDC signal. So we've eliminated the VFD from the variable volume, thus eliminating a lot of cost. Now, when do you use a variable volume system? So IECC 2015 states that anytime you have over 5,000 CFM in the exhaust system, you need to have a variable volume system, and it is recommended that that system be able to turn down 50%. Now, Greenheck has the product offering to be able to, on our variable volume systems, when you have a direct fired makeup air fan, the Greenheck variable volume system has an industry-leading 50% turn down based on the capabilities of our direct fired units. The other question that I'll get quite a bit from engineers is, hey, I'm doing a school. I'm just going to do constant volume controls. It's super easy. It's, we're just going to turn this thing on. It's going to run at 100%, and away we go. And the argument that or not the argument, but what I would contend that you should keep in mind is that typically, let's say we're doing a pretty constant application. So we are doing like a school or something of that, a university or something of that manner. If you have a constant volume system, let's say that system is designed at 3,000 CFM and it's constantly going to run at 3,000 CFM, the long-term energy cost of that constant volume is going to be way higher than having a system size for a variable volume system. Because in that school setting or in a bakery setting, somewhere where you don't have a lot of variance in your heat, you also typically don't have high heat. You typically have some pretty low, you're using ovens, you have some pretty low heating capabilities of those appliances. So if you were to utilize a variable volume system and have the slightly higher upfront cost, the long-term savings on that system would allow for the system to be truly running at 50, 60, 70% of design for the rest of the system's life, which is going to be a cost savings long-term on the system. The final thing to note when it comes to specifying controls is that I see a lot of times that folks are asking for fan and light switches on their controls. Just know, and I think this image shows it, just know that the industry has moved to whether you have a constant volume system or a variable volume system, you're actually going to have a touch screen that comes with that. We no longer, Greenheck and most manufacturers no longer use toggle switches. It's better for the manufacturing process to keep that LCD touchscreen, whether you have constant volume or variable volume. So nothing wrong with I guess nothing inherently wrong with specifying switches. Just know that the industry is moving towards more of a touchscreen application. And if you guys need any specification information on that, Tracy or his team could certainly get that specification to you guys. The final. So that's really it for the components to the KBS system. When you think about it, there's really not a lot going on. The hoods itself, they don't actually perform a mechanical function. They're essentially an upside down bathtub. It's the fans on the roof that are really providing the mechanical function to this. So again, that's where having that system, it's my belief that it should be the mechanical engineer responsible for doing the entire system, so that you have one system, one entity. So if something does go wrong on the job site, or if there are questions about whose scope or where it is, it eliminates those questions, and it allows for a cleaner job site construction. And I would argue that should be in the mechanical side, because you guys are trained in this. That's your discipline. Moving on to design considerations. So again, we're going to talk about design considerations and what all goes into designing a kitchen system. And just know that when Holden and their team, when they're laying out the Greenheck product for you guys, this is what they're considering when they're doing their design. And they're supported by our KBS sales team with any questions for any designs that are a little bit outside the box. So first and foremost, I would contend that the design of a kitchen ventilation system is very easy. There's things you need to look out for, absolutely, but it's really driven by the CFM volume of the system. Once you know your exhaust volume CFM, the rest of the system really designs itself. So the first thing that I'm going to call out here is that IMC no longer classifies UL 710 listed hoods, which all Greenheck Type 1 hoods are UL 710 listed. They no longer classify these hoods based on temperature. They used to do it on temperature. Now they just have light, which is Type 2, and then medium, heavy, or extra heavy. Extra heavy being for a solid fuel application. And just know that if you have an extra heavy hood classification, that needs to be on its own grease duct system. So again, solid fuel needs to be on its own grease duct system with its own hood. There can't be other appliances, gas or electric, underneath that hood. So once you have your appliance line, so what dictates this? Once you have your appliance lineup, so you're going to take a look at the worst case appliance going under that hood. That's going to dictate whether it's a medium, heavy, or extra heavy Type 1 hood. So let's just say that we had an appliance lineup with an oven, 2 fryers, a griddle, and a charbroiler. So a pretty standard, I don't know, like Applebee's type appliance lineup. We're going to look at what is the worst case appliance. So the worst case appliance is the charbroiler in that particular instance. So that is going to mean that this hood is going to have to be a heavy designation. So once we know that we have a heavy designation, and keeping in mind that when you're sizing these hoods, and we'll talk about overhangs a little bit later, but when you're sizing the hoods, the minimum overhang from the edge of the appliance needs to be a minimum of 6 inches overhang. So that's going to get us to the length of our hood. So once we've laid out that appliance lineup, we've determined the length of our hood, and we've determined that it's a heavy classification. Next is, okay, what is our airflow? Now, IMC is going to call for minimum airflows of a heavy application of 400 CFM per foot. That's going to be out of IMC section 507. That same section also calls out that any UL listed hood does not have to follow the IMC minimums, which is a good thing, because let's say we had a 10-foot hood, IMC would say we need to have a minimum of 4,000 CFM. Now, the next thing I'll call your attention to is UL 710 airflow minimums. So because we have a UL listing, we have minimum CFMs that these hoods can be sized to. And keep in mind, just like anything with UL, these are minimums based on perfect lab conditions. So if in a perfect lab condition, we were able to do 200 CFM per foot, that's probably not going to be enough CFM when we actually get into the field and we have cross drafts and we have cooks walking in front of the kitchen and we have pass-through windows. That's probably not going to work. So what Greenheck has come up with is our recommended airflow rates. These recommended airflow rates are going to be listed at the bottom here. And this is just based on our experience over time. You're going to see that they're much higher than the UL 710 minimums, but these are what we have found work through our years of experience within the kitchen ventilation system. So we would recommend an airflow of about 225 CFM per foot for medium, 275 per foot for heavy, and then 350 per foot for extra heavy or solid fuel appliances, keeping in mind that this is a wall canopy hood. So if you were utilizing a wall canopy hood in an island application, as we spoke about earlier, you would want these CFMs to be 20 to 30% higher, depending on the appliance lineup. And again, the guys at Holden are a great reference point for you guys to determine, hey, in this scenario, what do we think we're going to do CFM wise? Once we've determined the CFM of the hood, you need to make sure that your exhaust ductwork is sized properly. And what Greenheck would recommend is sizing the velocity in your ductwork to be 1,500 feet per minute. So again, the CFM value is CFM per linear foot of hood, and the velocity that needs to be maintained within the duct collar, we would recommend designing to 1,500 feet per minute. In most municipalities across the country, the minimum is now 500 feet per minute. There are still some areas, I'm actually in Chicago today, and Chicago is still, their code still says 1,500 feet per minute, but they allow lower, they allow lower velocities because of variable volume systems. So we've determined our airflow, we've determined the duct size, and then that's how we're going to size our fans. Makeup air is typically going to be sized to be 80% of exhaust. What problems could come up in this? Because once we have our airflows, what problems do you need to take into account? There's really not many. So designing a kitchen is pretty straightforward once you know your airflow, but there are some things to look out for. So what would those be? The first one, and probably the most common one, is swinging doorways or high traffic areas near the hood. So you can't necessarily, a doorway is going to be where the doorway is going to be, or a serving area is going to be where it's going to be. So you're going to have high traffic areas, but it's important for you guys to know where those high traffic areas are so that you know if you need to increase your CFM, if you need to provide end panels or end skirts to these hoods in order to mitigate these. But swinging doorways in high traffic areas, you should be on alert for. The next one, and probably the most controllable one by the engineering community in my experience, or in my opinion, right? But is the placement of diffusers and then the use of directional diffusers in a kitchen. So I would say that we would recommend never using a directional diffuser within a kitchen space. It just has the potential for that air to be shot back towards the hood and disrupt capture. And then ideally, you won't have any diffusers, whether they be perf or directional. You won't have any within 10 feet of the hood. Now, we know that is not always possible. We have these small kitchens that we're redesigning or just small kitchens that we're building. You have to get some outside air diffusers within 10 feet of the hood. But wherever possible, best practice design is to keep them at least 10 feet from the hood. The final potential problem to mitigate is just insufficient makeup air. So if we have insufficient makeup air, eventually that exhaust fan will be starved and capture will be affected. Excuse me just one second, a quick sip of water. The next design consideration is your overhang. So as I mentioned previously, the minimum overhang from the edge of an appliance where it's an open side is 6 inches. So if you have, let's say you had a wall on the right-hand side of your hood, you could go right up to the edge of that wall. There wouldn't be any minimum on that side because it's a closed side. Or if you have some sort of a full end skirt, it's a 0 inches from the edge of that hood. But if you have no end skirts and then it's always from the front, your minimum is 6 inches, which that's all fine and good. And it works just fine. We have our airflow sized at 275 per foot for our heavy hood that we're talking about. And we go right from there. But what I would like to call your attention to is keep in mind when you're designing a system that has those large like combi ovens or convection ovens. When you have ovens, large ovens, I would recommend a minimum overhang, or Greenheck would recommend a minimum overhang of 12 inches from the front of that appliance. And then in my personal experience, if you have the ceiling space, I always try to design for 18 inches of overhang. The reason for that is these convection ovens, they may be cooking baked potatoes or something for 40 minutes, right? So they're cooking these things at 400 or 500 degrees. And then 40 minutes later, timer goes off and the cook opens that door. Well, when that door is open, excuse me, when that door is open, that air is going to escape the oven itself, and it's going to go at such a velocity that if you only have a 6-inch overhang, you have the potential that it completely escapes the hood because there's not enough updraft velocity coming from the exhaust fan to capture that before it escapes the 6 inches. So if you can, with ovens, I would design for a minimum of 12-inch of front overhang, and my personal recommendations would be 18 inches. Now, again, that's perfect. I understand we don't always have that type of ceiling space, but something for you guys to consider when doing your designs. Same concept for dish hoods. Again, when these commercial dishwashers are running, the side doors are typically down, or they are down. So then heat is building up, condensate is building up. So then when they open, that escapes rapidly. And if you only have 6 inches of overhang, there's high potential for that to escape the capture area. And so I would recommend 12 inches from any 12-inch overhang from any door side of a dishwasher. So what do we do when we have to mitigate these? So you just have a door, you have a high traffic area. You have to put a diffuser within 10 feet of the hood just based on your ceiling height or your ceiling layout. What I would recommend doing is putting end skirts on these hoods. These end skirts here are going to enhance your capture and reduce the effects of cross drafts. So if you go back to your image of that door opening right here, if that door opens and you have the full end skirt on here, when the air comes from that door, it's going to be blocked by this end skirt. So it's a very cheap way to mitigate these simple problems in the field, and then you just don't have the problems when they come up. If you're working on a project that when it gets to a field, you find out that there are cross drafts that you weren't accounting for, know that these end skirts can be added after the fact. It's not always just, hey, I'm not capturing, let's just increase the CFM of the exhaust fan. Look at doing end skirts in order to increase the capture. And there's 3 types of end skirts. I need to update my rendering here, but there's the full end skirt, there's the mini end skirt, and then what's becoming popular in the industry and what Greenheck does also offer now is a full insulated end skirt. So that would just have this full end panel. That would just continue down to the floor with a leg on the bottom for that full insulated end panel. That's going to be your best end skirt. Full end skirts are good, but both full and insulated end skirts can be a hindrance to the cook when they're actually cooking in the field. Because if you have these end skirts, if you go, let's say you have a range at the end there and you've got to reach into your range, pull that back, and then move around the end skirt to put it on a table, that can become a hindrance. And a lot of chefs or cooking folks won't like that hindrance. So your option would be to do a mini end skirt. This mini end skirt actually does have some great, you'd be surprised how well this does help with capture. But this would be a way to help with capture without blocking the operations of the kitchen. And it would still help with capture. Now, an important note with mini end skirts, that does not eliminate the overhang requirements. So if you had full end skirts on the left and the right-hand side of this hood, again, that would be just like a wall, and you could have 0 inches of clearance from the appliances to the edge of the hood. With a mini end skirt, you would still need 6 inches from the edge of the appliance on that side. We're going to go through a brief 30-second video here, just for to show what the end skirts actually do in the field. We're going to see this, the smoke machine is going here, and there's going to be some rollout. So what happens when Andrew comes in, and he's going to go ahead and apply an end skirt to this hood. So we see we have some rollout going on. And then that end skirt is going to be applied to that hood. And we don't have any more rollout. So the next thing we're going to talk about is the evolution of kitchen design. So we're going to start with the past. We're going to move to the present. And then we're going to talk about the future, the present. It's kind of this gray area of what's going on. And it's really dependent on each project. So first and foremost, we're going to talk about what is the past. However, I do recognize that in Georgia, IECC, this part of the IECC code has been removed. So you guys still do have the ability to do short circuit hoods. But it's one of the last areas in the country that has that. We don't need to get into that conversation today, but I just want to point out that I do recognize that there's that exemption to you guys' standards. But what is a short circuit hood and why is it no longer used nationwide? So short circuit hood was a solution in the 70s where kitchens are, that air, that makeup air in order to balance a kitchen is expensive. If you're having to heat, cool, dehumidify all of that supply air from, again, our 10-foot exhaust hood that's exhausting 2,750 CFM, if you have to make that air up, that's expensive air. So the idea was that you would have a short circuit hood. So what that would be, and again, we won't spend too much time on this because you guys can still utilize these in your area, but I want to talk about why they're going away. So the untempered makeup air, the idea was is you would pump 90% of exhausted air back into this hood cavity so that you could balance the building. You didn't have to temper this air because you're putting it right in the hood. And then it would be quickly exhausted, which is great because that's untempered air, so it's super hot or it's super cold. Well, through years of study and research, what was found is that with these short circuit hoods, it was a good concept, but when you have 90% of your exhausted air being returned into the hood cavity, the velocity of this makeup air is so high that it's disrupting the capture of or it's disrupting the updraft velocity of the exhausted air. So it's actually causing air to go into that filter and then just cause conflation in the air so that you're losing either capture or some of that untempered air is escaping into the building. And then it's the building HVAC system is being taxed in order to keep that building comfortable. So IECC 2015 essentially outlawed short circuit hoods. However, again, Georgia IECC has an exemption to this clause, but the way that was done is in red here. The replacement air introduced directly into the exhaust hood cavity shall not be greater than 10% of the hood exhaust airflow, which essentially eliminated short circuit hoods because those rely on 80 to 90%. Again, fully understanding that you guys have an exemption to this clause. So with that said, we're going to move on. So that would be what we consider kind of the past of kitchen ventilation or the near past. So we're going to spend most of our time here on the present. And then we're going to go through 3 different examples of 3 different types of design, one of which utilizing DOAS, which I would consider the DOAS factor of the future, right? So the present. Most kitchens in America today are designed this way, where we're going to have an exhaust fan, best practice being 1 exhaust fan per exhaust collar. Again, fully recognizing that in some instances you have to have multiple exhaust collars to an exhaust fan, but best practice would be to have as close to a 1-to-1 relationship as you can between the exhaust fan and the associated exhaust collars. From there, we're going to have a dedicated makeup air unit that's going to provide excuse me, that is going to provide supply air through an ASP plenum at the hood. This air is going to create a curtain. It's typically going to be, this is not a technical term, but it's typically not going to be creature comfort air, so it's not going to be dehumidified. The non-technical term I use is, I like to think of it as cutting the air. So you're typically just going to cut that air to get it down to about a leading air temperature of around 70 degrees. And then you're going to bring that air, so that lightly conditioned air, into the space. It's going to be lightly conditioned and it's not going to be dehumidified. So it's not a perfect solution, but at least it's not super expensive air because this provides an air supply curtain. Most of that air is going to be quickly exhausted. The air that is not, since it's been cut, typically the HVAC system can dehumidify and actually get that down to creature comfort. But I will say, I mean, in some instances, I always share, I was a cook at Applebee's when I was in college. And I went to college at the University of Wisconsin-Stout in Wisconsin. And I don't know if it gets quite Atlanta humid up here, but it gets pretty dang humid. So in the summer, our kitchen makeup air was untempered makeup air, essentially. That kitchen was hot. It was uncomfortable, but hey, it was fine by code. And then they heated the air in the winter. Now, sometimes these dedicated makeup air units, you guys will see a direct fire makeup air unit with a packaged DX cooling system. So then again, we're going to be cooling that air. But since we're not cooling it down for dehumidification, it can still be humid in that kitchen, but at least it's a little bit more comfortable. And then finally, with the present, you're making up the rest of your transfer air or your outside air through transfer air from your rooftop unit. And then we touched it already, but those would utilize diffusers, and we want them to be 10 feet away from the hood. So I want to talk a little bit about the plenum itself and the two different kinds that we see used most commonly. The most common plenum in the market is the first one here, which is that ASP plenum. So we have dedicated makeup air coming through this ASP plenum. It's providing an air curtain, so it's providing a slight assist to the exhaust, to the capture of that hood. A good portion of that air gets immediately exhausted. The rest of the air goes into the kitchen, and the rooftop units are attempting to dehumidify, to cool that air, to condition that air. That's the most common. The next product that you'll see in the marketplace is in this upper right-hand corner. We have what's called a split ASP. Now, this is a good solution if you can't have, so if I go back one slide, if you can't have diffusers 10 feet away from the hood, but you still want to utilize that rooftop unit for your transfer air or for your pressurization, you would actually have this split ASP. So you would still have your dedicated makeup air, which is designated by these blue lines coming in the front. And then this front plenum is an insulated, typically 10-inch wide plenum that can accept air from your rooftop unit, and it can be placed within 10 feet of the hood because it's still coming out of downdraft. So it doesn't have any possibility of coming out of a diffuser and disrupting the capture of the hood. So that would be an option. Again, that's the split ASP option. If you don't have enough space in your kitchen for diffusers not to be within 10 feet of the hood. The final product that Greenheck and other manufacturers offer is a back supply plenum. Back supply plenums are commonly used when you have untempered makeup air. So if you have truly untempered makeup air, you would utilize a back supply plenum so that you're not dumping all that untempered makeup air on the cook's head from this ASP. You're going to bring in a significant portion of your outside air through this back supply plenum, which is a 6-inch wide plenum mounted to the wall that cuts off 32 inches from the floor. And then the air is returned in at the 32 inches above the floor. And again, a lot of times that's untempered makeup air. So you're pressurizing the building still, and you're still making up your outside air. However, you aren't dumping untempered makeup air onto a cook. So we're going to talk about the DOAS factor in kitchens. And now this is becoming more and more popular as we look across the country. And there's a reason for it. So, but does every kitchen really need a DOAS unit? And the answer is really, what's the budget of the project? But what is the goal? You know, when you guys are speaking with your clients on the front end, what's the goal? What's the scope of what's going on? So everybody has different opinions on why DOAS is becoming more prevalent in the kitchen ventilation marketplace. My personal opinion, and again, there are differing opinions out there, but my personal opinion is that chefs and cooks and folks working in the restaurant industry, previously they didn't have much choice. They just accepted the fact, if I'm going to be a cook at this restaurant, like I'm going to be a cook at an Applebee's, it's going to be hot in that kitchen. They're going to heat it during the winter, but they're not going to cool the air during the summer. And I just accept the fact. And if I don't want to accept that, then okay, I can go find another job. And again, this is all my opinion, but I believe that the DOAS coming in is a lot of employers recognizing that their employees have choice. So they need to be comfortable at work. So they need to have the kitchen makeup air needs to be fully heated, cooled, and dehumidified. That's my opinion on why DOAS is coming in. It's more expensive to do this way than it is the traditional way, and we'll go over that in a moment. However, what is the client's expectation on the front end? What's their budget, and what are we trying to do with this project? So first, we're going to really quickly touch on 508.1.1, which is the ultimate question. Do I heat? Do I cool? Do I dehumidify? What in the world do I do with this air? And to be honest with you, I never really understood till years ago, I didn't really understand why is this even a question? The first line here says that the temperature differential between makeup air and air in the conditioned space shall not exceed 10 degrees Fahrenheit. Well, I can tell you that when it's 85, 90 degrees here in Wisconsin or here in Minnesota, that air was coming in at 90 degrees. Like, what the heck's going on here? That's within 10, that's outside of 10 degrees. But it's the second portion. So except where the added heating and cooling loads of the makeup air do not exceed the capacity of the HVAC system. So that's just giving a lot of deference to the designing engineer to say, yep, my system can handle this. I'm going to bring this air in such a fashion that I'm only going to heat it. I'm going to heat and cool it, or I'm going to dehumidify it. It just gives a lot of flexibility to the designing engineer. There's a lot of deference to you all. So, like I said, we're going to go into a couple of different scenarios here. This was a project. It was a Casey's General Store up here in, I believe this one was in Iowa, that had Greenheck units on it. And there's 3 different ways that this system can be laid out. It's the way that it was laid out. It can be laid out this way with a traditional makeup air unit and an and a rooftop unit, which I think we've already touched on this, but the primary function of the kitchen makeup air unit is just to replace that exhausted air with a high percent of outside air. If we're heating and cooling, it's to temper that within 10 degrees of the space. And then, you know, your traditional, your rooftop unit is controlling the space and temperature and humidity, and then meeting outside air requirements, recirc, outside air, all the things that traditional RTU unit is doing. So let's look at our first general store example. And again, I'm not saying, I have my opinions, and I'm sure all of you all have your very valid opinions as well as to the right way to do things. All of these are technically correct and they work, but there's different costs associated, and we all have different opinions on how these designs should be laid out. So my goal is to really just show you guys 3 different ways that these are laid out. So again, a Casey's General Store, I'm not familiar with Atlanta, what you guys' comparison would be, but these Casey's, they're gas stations, small footprints with, you know, think of a small footprint gas station. So what they were doing in the original design is they were actually utilizing a direct fired makeup and cooling makeup air unit. So this was a high percentage of your outside air. They were utilizing a DOAS unit, and then they were also utilizing a rooftop unit. So again, that works. It's not technically wrong. It's not, in my opinion, it's not the best design in the world, but how else could we approach this space? And this is what the conversation that we had with them at the time. So we could do a traditional space. We could do the makeup air unit with a rooftop, or we could use DOAS and replace all of the supply units. So option number 1 is to go traditional. So that DOAS was, I'm sure you guys recognized from that first slide, that was being heavily underutilized. So the tempering benefits aren't there when you're utilizing such a small proportion of the total makeup air. So this design is going to be drastically cheaper, and it's going to save on overall roof floor plan space. However, the big loss here is we are eliminating humidity control. Most of that makeup air, we're going to increase the makeup air percent on the hood to absorb the outside air from the DOAS unit. So most of this makeup air is going to be that traditional, it's going to be heated and cooled, but we're totally eliminating humidity control. So that kitchen has the potential to be very uncomfortable. However, it is a much lower price point. The next thing that we're going to do is we're going to fully utilize that DOAS and its tempering and recirc modes for the entire space. So we're going to remove the makeup air unit and the rooftop unit. So that's going to save us on space and costs from the first design. And then we're going to increase the DOAS's outside air by absorbing that outside air. We eliminate the need for the makeup air unit. So that's going to eliminate that roof penetration. So you're going to have less roof space and less penetration. And then you'll eliminate the supply plenums at the hoods and only utilize diffusers in the space, because you wouldn't want to dump is probably the wrong term, but you wouldn't want to place too much air into those air curtains, because now this is fully tempered air. So this is expensive air moving forward. We don't want there to be the possibility that it is exhausted almost immediately from that air supply plenum. So those are the 3 different options. Again, I think it's pretty straightforward. Everyone can have their opinion on this. I actually lean towards the traditional. I come from, my attitude is really, if it ain't broke, don't fix it. And kitchens have been working this way for years with no problems. and this more cost-effective way. So the original design, it was just underutilizing that DOAS, and higher price point, the highest price point, underutilizing the DOAS, just not a great design. Again, it worked, but not great. The traditional design is going to be that least expensive, right? So that makeup air and the rooftop unit, that's going to be your least expensive, but we lose humidification. And then finally, kind of that midpoint is your DOAS unit, right? So it should be pretty straightforward. Or I don't want to make that assumption because you guys can't chime in, but with this DOAS unit, you're going to have your most cooling value. You're going to have a single roof penetration, so that could be very important depending on your roof space. You may just not have the roof space for a traditional makeup air and a rooftop unit. So we're going to have that single run of power, reduced penetrations in space, and the big one, full temperature and humidity control. And then a smaller but not insignificant item would be a single unit to lift, a single crane to lift a single unit on when they're doing construction. With that, I'm trying to keep an eye on the time here. I'm just going to go over a couple additional, really just one additional KBS product that I want to make you guys aware of. Again, if it moves air in a kitchen, Greenheck has the product and the quality product to do that for you effectively, and Holden is going to be a great resource for you guys. The one additional product I do want to highlight is this is our Greenheck GRRS residential range hood. So this is for when there's a residential range in a commercial setting and that food is not being sold for profit. It's also going to meet NFPA 101 life safety requirements for 500 CFM, for having manual pull stations, and auto clock lockouts. And if you guys need more details on this product, we can certainly get that to you. But it's also going to be UL 300A certified. So it has a 300A certified fire suppression system in the hood itself. Now, this can only be used over your standard residential ranges in a commercial setting that are either 30 inches wide or 36 inches wide. There's no overhang from the range. It's just, those are the most common residential ranges on the market. And again, that's 30 or 36 inches wide. And then the question just becomes, do you need to have NFPA 101 for life safety? Where are you looking for these? So schools, college dorms, nursing homes is probably the most popular place that we see this. Fire stations, police stations, becoming more popular. Nursing homes, I think of the example, my grandma's in a home, so they have a common area for cooking with a residential range, so we could come do Thanksgiving there. So all the cousins and everybody would show up, and we would cook our food for the family on this residential range, so it wasn't all in her little apartment. So we'd all go down there. The nurse or whomever would punch in a code in order to unlock the range and allow us to cook. And then that we'd be able to cook on that for 2 hours before the NFPA 101 would shut the gas or electric going to the range off. Reason being, if we do have our big family gathering and we walk out of there and we forget to turn it off, that building isn't exposed to a range that could potentially be a fire hazard. Just a little image of these installed versus not installed. The Type 1 hood, here in the old image was our residential range, but it was in a commercial setting, so we had to have Type 1 hood, grease duct, exhaust fans, makeup air fans, supply plenums, all that. Grease. I think I mentioned grease duct already. Now with this residential range, we have our fully contained fire suppression system. It's hung. It's very easily hung on a wall-mounted bracket. That the contractor installs the bracket, drops this thing onto the 2 brackets. It can tilt forward. You pull the little pin to arm the fire suppression system. Away you go. And then the big thing on the back half of this is you don't need grease duct with these. It's just spiral. So what can Holden do for you? You guys as local KBS experts. They're supported by myself and my team at I'm out of Minneapolis, but our team here. Again, they're going to design these systems based on your client's needs. So if you guys have these initial conversations on the front end, and I'm seeing a bunch of chats pulling up, sorry, cater to you guys' needs. So have a conversation with you guys and make sure that, hey, is this the right application for a DOAS, or is this not the right application? And then finally, the big one for you guys is day-to-day. Oh, that was weird. I'm sorry, I just had my computer kind of glitched on me. The big one for you guys is day-to-day is quotes and drawings. Again, we went through a lot of design considerations today, and it's important that you guys understand these so you can have educated conversations with your clients. But ultimately, if you can just get the floor plan and the general, roof plan that you're looking at for these projects, your Holden rep is going to be able to get you quotes, budget quotes, drawings, whether that be in PDF, AutoCAD, or full Revit content. So with that, I think I am right on time here. Please reach out if you guys have any questions. I've seen a couple come up in the chat. Sorry, I'm still not an expert at Zoom, which you would think I would be this far in.